Hello and welcome to Virtual Learning Network. This e-lecture is on Computer Basics and PC Software, Block 1, Unit 1, Part 1. Introduction to Computer, their origin and applications. The topics we are going to cover are Origin of Computers, Computer Generations. In Origin of Computer, we will learn abacus, Napier's bones, slide rule, Pascal's calculator, Leibniz multiplication and dividing machine, difference engine, the analytical engine, mechanical and electrical calculator, modern electronic calculator. In computer generations, we will learn all the 5 generations of computer. So let's begin with introduction of computer. We all know that computers can be designed to do almost anything with information. Computers are used to control large and small machines, which in the past were controlled by humans. Through computer, we can listen music, read the news, and write anything. Computer is the most powerful and versatile tool created by human being. The word computer comes from the word compute, which means to calculate. Computer is an electronic device which performs 3 basic tasks: inputting, processing, outputting. A computer accepts the input through various input devices. Computer perform different operations required by the user on these input. Computer generates the resultant of the processed data as the output through various output devices. Origin of computer. Origin of computer could be difficult efforts of man to count large number, so different techniques are used. Now let's start with abacus. In childhood, we all saw abacus. The word abacus means calculating board. The abacus may be considered the first computer. The abacus is also called a counting frame, which is a calculating tool for performing arithmetic operations. So, a basic abacus consists of 2 rows of beads arranged in a variable number of columns, as seen in this figure. Each column in the top row should have 2 beads per row, while each column in the bottom row should have 5. The beads in the top row represent the number value 5 and each bead in the bottom row represent the number value 2. Now, Napier's bones. John Napier was a mathematician who became famous for his invention of logarithmics. The use of logs enabled him to reduce any multiplication problem. John Napier built a mechanical device for the purpose of multiplication. The device was known as Napier's bones. Next one is slide rule. Slide rules was developed by E. Gunter. This machine could perform operations like addition, subtraction, multiplication and division. All through, the slide rule appeared in various forms during the 17th century. It consists of 2 movable rulers placed side by side. The slide rule is actually made of 3 bars that are fixed together. The sliding center bar is sandwiched by the outer bars, which are fixed with respect to each other. The metal window is inserted over the slide rule to act as a placeholder. A cursor is fixed in the center of the window to allow for accurate readings. Next one is Pascal's calculator. Pascal's calculator is also known as an arithmetic machine in which we perform all arithmetic calculations. Blaise Pascal was a French mathematician and one of the first modern scientists to develop and build calculator. Pascal's calculator is a mechanical calculator. The first Pascal line could only handle 5-digit numbers, but later Pascal developed 6-digit and 8-digit version of the Pascal line. Leibniz multiplication and dividing machine. Gottfried Leibniz was a 17th century scientist who recognized the value of building machines and built around 1673 a mechanical device that could do mathematical calculation and save labor too. Next one is difference engine. Difference engine was designed to calculate values in a polynomial equations, which it did by combining several mechanical adding machines together. Charles Babbage designed for the first automatic mechanical calculator. The difference engine was a special purpose device intended for the production of mathematical tables. It was a special purpose device intended for the production of mathematical tables. Next one is analytical engine. The analytical engine was to be a general purpose, fully program controlled, automatic mechanical digital computer. It would be able to perform any calculation set before it. The analytical engine contained an arithmetic logical unit ALU, basic flow control, punch card, and integrated memory, and is the first general purpose computer concept. The analytical engine has many essential features found in the modern digital computer. Mechanical and electrical calculator. In the beginning of 19th century, the mechanical calculator was developed to perform all sort of mathematical calculations. Up to the 1960s, it was widely used. Later, the rotating part of the mechanical calculator was replaced by electric motor, so it was called the electric calculator. Modern electronic calculator. Modern electronic calculator. Nowadays, we all use this calculator, so it's not difficult to understand for us. An electronic calculator is a small, portable electronic device used to perform operation ranging from basic arithmetic to complex mathematics. Now, we are starting with computer generations. There are 5 computer generations written below. First generation computers. First generation computers are characterized by the use of vacuum tube. These computers were too bulky in size, which required large room for installation, and they used to emit large amount of heat. So, air condition was must for the proper working of computers. In this generation of computers, programs written in high-level programming language retranslated into assembly language or machine language by a compiler. Second generation computer. Second generation computers are characterized by the use of transistor. Transistor is a device composed of semiconductor material that amplifies a signal or opens or closes a circuit. In the second generation, the concept of central processing unit, CPU, memory, programming language, and input-output unit were developed. During the second generation, many high language programming were introduced, including Fortran, COBOL, etc. Third generation computer used integrated circuit in place of transistor. These integrated circuits are popularly known as chips. The integrated circuit technology was also known as microelectronics technology, since large number of circuits could be integrated on a single chip. A single integrated circuit has many transistors, resistors, and capacitors along with the associated circuitry. Computers smaller in size, they are reliable and efficient. Remote processing, time sharing, multi-programming operating system were used. Fourth generation computer. The microprocessor has thousands of integrated circuits were built onto a single silicon chip. The major innovations in this generation were the development of microelectronics and the different areas in computer technology such as multiprocessing, multiprogramming, time sharing, operating speed, and virtual storage. During this period, high-speed vector processor changed the scenario of high-performance computing. Last one is fifth generation computers. Fifth generation computers are based on artificial intelligence. Artificial intelligence is the branch of computer science concerned with making computer behavior like humans and allow the computer to take its own decision. The greatest advances have occurred in the field of games playing. In this tabular representation, features of 5 generations of computer are defined. Now it's time for summary. Computer is an electronic device that performs mathematical and non-mathematical operations in order to achieve the results. Its first generation used the vacuum tube. The second generation used the transistor, which were much smaller than vacuum tube. Integrated circuits were used in third generations. VLSI comes in fourth generation computer. Now fifth generation growing towards parallel computing. Thank you for this session.